Okay, so we want to now collide the spikes, and in a way that's much better than this. Which means, this looks to me like the right-hand side of the spike is what's, that's what we're almost tracking with this. We can tell to see what we're getting here. For our physics, we're getting, let's see, handle collision. Here's our other game objects. I can just debug this. And we can just, every frame, take a look to see like what is in here, and then we'll look at those last frames to see what, did it really just check to see the first time that a spike entered in, which I think it does. So here we go, we have other game objects. Start, then nothing, nothing, and then our spike up. Okay, so our spikes up location is 250 by 350. Is our spike in the correct location on the map? Let's see, 250 divided by... Let me open up you. So you're position 5. I kind of wanted to redraw the grid again. Let's go ahead and turn that on. So you'll be happy there, and then okay, 0.2, and then graphics there. I'm doing like the full reach in and like figure this out because this is often commented out. I'm not seeing. Okay, what happened? So we figure out what you are. Am I calling draw? All right, so where's our grid in here? Oh, because we have the camera draw. We don't have the grid draw very often. So let's have the grid draw at the very end. Your results. Okay, so you're the custom error, and we're returning obviously a game result here. Then we just want to go ahead and return error with the error in it. Oh, and we can actually grab this error out. Okay, so then we're throw that error in there and we return that. Otherwise, probably like debug what this is. Okay, custom error doesn't implement standard debug. Let's fix that. All right, so no errors left in U. Let's go ahead and run this again and see what's happening. There you go. Okay, so we have our grid now, and we can see 0, 1, 2, 3, 4, 5. So the spike's in the correct spot. Oh, that's fun. Wait, did that like replicate? The grid freaked out. Okay, hold on. We can see it for... I think we're dying from the first spike, but maybe like the camera's not moving, like the camera's moving maybe too much. That's kind of weird. If I don't turn on the grid again. Where's my draw? This is grid. I want library. Okay, here's my draw grid. Just go ahead and not do you. It looks like it's entering into the second spike, but I think it's dying from the first spike. And I'm wondering if my locations are a little bit off here. So I'm offset the camera. Now if let's say I don't offset the camera. What if I don't update the camera? Say don't do that. Okay, so that is still happening on the second, what looks like to be the second spike. And I don't think the player needs to be fully in there. Now that being said, is the player's location like farther to the left than I think the player is? Is that my problem? Because I think I have, let's see, what is my player width? Here's my player. Okay, I have body width and body height as my width and height. And my location is the start X and the start Y. So it should be like right there. I don't think I'm doing anything so like moving, like when I create the mesh. So here we get the width and the height. Yeah, we're creating this at 0, 0. So its location should be the left-hand side, and the body top is at like top. We're ignoring the head, and then the width and the height. So that seems to be correct. When we move the object, we're moving it out of cells and into the next cell. I'm wondering if I just need to also get the cell to the right. So in the grid, when we run our update, these are handle collision, and we handled the other game objects. Right now, we're cloning. We clone our cell. I also need to clone the cell to my right. Wonder if I can do that here. So other game objects. So we're just grabbing out, say, the cell clone. Okay, we're iterating through that, checking to see what objects there are in here, and they're collecting that in there. So I could theoretically now add in, clone the next cell, and iterate through it. So if there is another cell, which means I need an index, I need the X index, which I can get right here. And then the cell is exactly the same. Okay, so we have that. Then our X index, if, okay, so as long as X index is less than whatever, like the row dot length. Okay, so if we have another one, let's actually do less than row dot length -1. So that way, okay. We know that there's another one to our right then. What are you upset about? Cannot borrow row as immutable because it's always already borrowed as mutable. I mean, sure. I mean, I don't. I don't want to have to clone you. We could just store this in self as a number, so we like just know what our lengths are. Maybe that would be good. So we have the cells, we have the so we want like how many we have down, how many we have to the right. Maybe to begin with, we'll just go how we have to the right. So grid width. I don't know if this really matters what it is. We don't know how big it should be. So let's do like a U32. Okay, grid width is going to be R. Basically, whatever this is. Cell width. So for X count, user cell width. Oh, this is gonna be -1. So cell width -1. Now the cell width is actually is that true? I guess it is. Cell width. No, it's a cell size. Okay, so that's not correct. I have a feeling my grid, like when I'm creating the grid, I don't think I'm creating it in the right way here. Because I really want. Okay, so world height is correct. We're going down by like that amount. And that creates a row. But for every single one of these, what I really want is to figure out the number of cells that we have in the level. Multiply the, go by the number, so it's not the grid width, because this just creates 50. Oh, okay, I haven't created the cells correctly. Ooh, that's the reason why we're off here. Our grid is not created correctly. So hold on, before I do this. Let's go back to our whiteboard and figure out this math. So we have each of these cells as we're creating. What I want to do is, if the level is this long, like there's that many elements in the level, I want to create this many cells in the row. So I need the number of elements in the level, which is the level.length. In the game data, we have the level here, which is a vector of type. So whatever the length of this is the width of the world. So that means in our grid, we should definitely be able to get in. Okay, so we have the cell width, the cell height, the world height, and then the world width, which is probably like a U32. We can store this away. And then here, okay, so Y count, this is going to be for in the world height. And then for you, row, we want you to be in the world width. and then store you away here. Okay, so that gives me, I think our cells are going to be correct now. And now I want, okay, so handle collisions. Okay, so if x index is less than, oh, now you're okay with this. Or is it just because I have other errors and that's the problem? Let's figure out these other errors before I do this. Okay, so when we create the grid, we also want to create the world width. So that's going to be game data. Okay, the length of the game data, expected U32, found U size. Okay, no errors. Back to the grid. Now, before we call handle collisions, we want to check to see. So if our x index, as long as it's less than self.world width minus 2, I want to say. Because if it's -1, we're at the end. If it's -2, we're 2 from the end. Mismatch types, expected U size, find U32. Oh, fine, I'll just store it as a U size. That'll just be easier. Which means I can come back to here and not change it. So okay, here we go. If this is less than that, so there's one more room to the right for it, let's grab that cell and hand it in. Also, you know what? Before we run this, we just changed how the grid works. Let's just see what our collision detection looks like now. I bet it works better. Or it's exactly the same. Okay, never mind. We want to now get all of the objects. I don't need to filter them. I just need to iterate through them and put a reference to them inside of other game objects. And we have our y, so we have the row. So in our current row, but of the new x index, that gives us our cell. Then we want to get an iterator through this. And then just push a reference to this game object into here. And then we can check our handle collisions with that too. So see if we're in the same, like the cell next to us. See what that looks like. Oh, mutable borrow list that are used here. Right, I forgot we do need to do that clone. So I think we can do this all together here. We first clone. and then we borrow, but, oh, cannot borrow row as immutable because it's also borrowed as mutable. And that's why I'm doing my cell clone here. So what if I do next cell clone? Which of course only happens if I do it as an option. I can do like cell clones. So I'm cloning myself because I have you right here. I wonder if I really want to do this, or if I want to like switch away and do a query. So right now I have this query that allows me to say like, here's some coordinates. Here's a rectangle. Give me a reference to all the objects inside of there. The problem is I can't pass like a reference to self into the physics engine to allow it to like reach back in and run that query. So I would want to run the query right when I pass this in. So I wonder if I want to do that instead. Then I wouldn't have to do any of this cell clone nonsense. I wouldn't have to do any of this filtering. Would probably want to do in the physics module itself. If possible, I would like not to clone the row, because I'm already cloning one of the cells. So that would be like a double clone there. Oh, temporary value dropped here. Which value was dropped? Wait, which value was dropped? The index? Or the clone? Oh, it's because I added in a clone, so it doesn't like that. Okay, so I don't think I can call a query here. So like if I want to do this as an example, let's say, let's undo you. It's like you all work. We're handling the collisions by just like grabbing out, cloning the current cell that we're in, and then getting these game objects. And I don't think I can like pass in like a reference, a pointer to the query here. That seems like it wouldn't work. Oh, I can't imagine it working. Let's see. Let's see what happens. If I do self.query and I just say, hey, I want starting at game object location.x. index will be like one full thing over to the right. So let's just say it's if we happen to know, let's just do 100 to 0 for right now. I can't imagine this is gonna work. I just want to see if it does. It's gonna be like 50.0, so it's just one cell downward and 2 cells to the right. Yeah, okay, so cannot borrow self is immutable because it's also borrowed as mutable. Immutable borrow occurs here, and yeah, so we can't do this like self like this. Because cell, this query is an immutable borrow. And like I couldn't like, you know, do, hey, let's do mutable here. I think that's also gonna cause the same, like, hey, now you can't borrow it twice. So it's not like just that's the problem. Hey, do I end up using where self debug? I did. I did temporarily. And then I think, how did I figure it out? Oh, I cloned. I just implemented clone, which did that. But I think in our physics, yep, we do that right there. So we actually do have the where self debug. So yep. Also, hey, hello, Rizex. Yeah, this was a really cool trick that you showed us. And it works like a charm. Now we're not using generic types, but because the standard library is, and maybe like other things are, that's why we have to do this, is to tell it like, hey, like limit your generic types to here. So we're kind of telling other people's generic types what we're passing in. You can also use such a trick with aliases. Really? I haven't used aliases before. So right now we're trying to figure out how do I get the next cell and pass it into our handle collisions here. So obviously this self query is not going to work. I don't want to clone the entire grid. Although I do know that some games do this. You clone the grid, so that way you can you could do all your physics and everything else, and then you replace the grid. So you're constantly like swapping the grid around like that. And this game is simple enough that I could clone the grid, but I'd like to figure out a way not to have to do that. Okay, so I don't think I can do the cell to the right. So here's we have this. Here we go. Cell clone. So we have like our own clone. If I try to do something like, okay, let cell right cell. Because then this is just going to be like row of position x index plus 1 dot clone. And again, I think it's going to be the same problem. Our row is borrowed as immutable here. I wonder, can I just reach in and grab it out directly from the grid? So let's try this down here. So like the cell to our right. Position. We don't have a Y index, so let's change that. Cannot borrow self.cells is immutable because it's also borrowed as mutable. Right, I would have to do something like clone all the cells. Like I have to clone you to be able to reach in to clone it again, right? Oh no, because self. Yeah, cannot borrow self.cell. Okay, so this is like a problem all around. So I wonder if I want to separate this out into a bit. Everybody do your update. And so we do like one loop through to do your update. And then we're gonna have to partition out the cells and say, okay, here's all the game objects. Like we're gonna have to like do handle collisions. Now in this specific game, the only thing that does collisions is the player, right? So we don't have to care about like where that is. Let's see. If I move handle collisions out, we have everything move in just like this one update here. We just say like, hey, you're all updating, do your normal updates. And then we do your handle collisions. And we do handle collisions within each set of cells. So loop through the grid and grab these two cells, but handle collisions. Then grab these two cells and handle collisions. But what if these ones need to then? So handle collisions, handle collisions, handle collisions, handle collisions. Have everybody handle their collisions. So that like goes through the entire thing. That way, when the player is like halfway into here, it checks both of the cells and then handles the collisions properly. I think I might end up liking that, even though it's a little bit more work and like more loops through here. What this ends up meaning is that we don't handle collisions here, meaning that we don't get our game objects either. So if I comment you out, all we're doing is the updates and the moving through. So at this point in time, it should still work, but we should ignore. Yeah, we're gonna ignore and then move through. Oh, did I turn off the camera? I turned off updating the camera. Let's fix that. Of course, we go off the edge of the screen and crash because we go past the end of the level. But that's all in fine. What that means is now after update in the grid, this is gonna like handle cell moves first. It's like just move the objects. Then collide the objects. I wonder if I could just do this as like move game objects. Like that. You don't become public anymore. So that way you run and you just do all this stuff. Then we're gonna have another one. And then we call this from here. So move the game objects. That brings them into their new cells. Then handle the game object collisions. We'll just deal with this separately now. So if I, for each cell, grab the cell and a cell to its right. How would this end up working? Because I don't want to accidentally run collisions multiple times. I wonder if like, do I want to say, okay, handle all of your collisions with yourself. So basically, okay, everything that's within here, collide, and then just be aware of here, and then you collide with them. And then everything in here, you collide with them. Then they will never collide left. Is that true? I guess like in this case, it doesn't really matter because I'm not having them affect each other. It's just ending the game. It's just ending the game. If I had, however, like a bunch of, I don't know, particles and they were connecting with each other and they hit and now I want them to bounce away. And like the grid line was maybe like here. Then the one, when it hits to the right, I want it to tell the other one, okay, you go and move and like do something. And if I do that, then it can't be a clone, can it? It's gonna have to be like the next state. I don't have to worry about that right now because of the simplicity of like the collision that we need. It's not even really, well, I guess there is collision detection. We need to check to see if we're colliding with, I guess eventually the floor and also the spike. So in our physics, we're gonna have this handle collisions here. And that's gonna give I'm probably just going to switch away from other game objects and just have it be like, here's everything in this cell. And I wonder, should I just hand it a reference to the cell, or should I actually just extract everything out? All right, so I guess we want to start by looping through. Do I want to take a clone of the entire grid before I start this? Like clone all the cells? And then replace all the cells with the cloned one after they like do all their moves? Probably not. But I need to loop through this with the intention of grabbing 2 at a time. Okay, so let's get the row. So I have the row, and I could get the Y index too. If I just care about the X index right now, let's get our own cell. I could loop through the row and I'll get our current cell, but that won't give me the next cell. Maybe I have to do like my own loop for this instead of like using the iterator. So we're going to go from 0 through the end minus 1. So we're never going to handle like the last box on its own. It's going to be just like close to the end. So it's going to be the row dot length minus 1. And now I want to extract out the row. Okay, so current cell. Okay, so now I have both those, but problem. Cannot move out of here. So I don't actually want to move out of here, do I? I want this to be a mutable, just a reference to it. Okay, so now I have a mutable reference to the hash map in the current cell and the next cell. I want to combine these two together into a single vector. So this could be like let mute. There's a way to get them all, right? It's an iterator. Okay, oh no, so that's just values. Okay, so I want to, for our hash map, is there anything that will just like get everything and like throw it into, like, can I collect essentially? Oh, I can turn it into an iterator and then I can collect on that maybe? So values, that gives me an iterator, then I can collect on that. And that's gonna give me let, type annotations needed. Okay, so I'm gonna collect. And you're going to be, I just want the game, but not straight up. I want like mutable references to the game objects. Oh, and I want you to be a vector. Or do you vector immutable game objects, but you can't do that, I guess. Oh. Give me the air. Oh, okay. So tuple this. Do I want to extract out? I don't want to filter. I guess I just want to map. So I'm first gonna get, like we're gonna get the ID and then the value. So it's gonna be the game object. And I want to turn the game object. Put you right there. Okay, so here, now I have a vector of mutable game objects. Okay, so I have this now. Oh, row. Yeah, I cannot borrow row as mutable more than once at a time. Okay, so that's our problem here. I'm trying to grab you. And I don't want to grab you twice. Okay, so can I do something tricky with like a block and like extract you out? What if I don't, what if I also do y index? Just y index in okay, so we're gonna go all the way down exclusive, so it doesn't include like the bottom one. And then we're gonna go all the way across. So this is gonna be the self dot world width, and we can actually just do the world height here. So we do need the world height. World height is a U8. Okay, so 0 through self to world height. and then world width -1. Okay, then current cell, we want to reach in directly and say, okay, give us self dot cells position y index, x index, and that gives us cannot be indexed by U8, must be a U size. Okay, so that gives us the current cell, and then we're going to do the exact same thing here. Let's see if this works. Cannot move out of, okay, so I don't want to move you out. I want to get a mutable reference. Okay, cannot borrow out of you. So what if I do something like this? Create a current cell, then do a block, and then set you equal to here. And then you end here, and I'm not using you anymore. Are you happy? Cannot borrow stuff to cells more than once at a time. I don't want to borrow more than once at a time. I want to just grab you out of here. But I guess, okay, so let's clone this one. Temporary okay, so yeah, let's go back to not doing this trickery. There we go. Okay, then we want problem. When I clone it, I'm not using the originals. I'm not getting the original cells anymore, which means that whatever collision stuff that I do is not actually going to affect it. I really want the current cells, like the actual like current cell stuff. I don't want a copy of it. I want to reach in and say, okay, give me the current cell out of here. And then you're done. But I guess like I'm mutating, or I'm getting a mutable reference to cells. Can I get a slice first? Like in one go? Like, so I want the X index, that's fine. And then I want a slice. As mute slice. So that's, okay, as mute slice, how does that work? Extracts a mutable slice of the entire vector. Wait a second. Okay. That gives me this array here. Like then a position X index? That doesn't seem right. How do I do, okay, there's not a slice for, let's see, this is a vector. Let's go to vector. Yeah, I don't want to replace. I just want to like get a, to slice it out. Wait, didn't it show equivalent to @mute s that? Is it inclusive or exclusive? So what if I do, let's see, @mute s. So, so let's do like our cells, our two cells. So we want the y index, that's fine. And then the x index is going to be like this. From the x index dot x index plus 1 plus 2. I don't need that. And then I have two cells here. What do I have? So this should give me like, okay, if I do this once and we just panic and like exit the program, I should get an array of two things. Also, what's this random state? Oh, there it is. Okay, we got a two cells. So then for both of these cells, I want to now iterate through these cells and put the game objects together. Which I guess, let's see. This collects them. It's like this is the first set of game objects. Here, let's do it like the good old, not like efficient way first. Create an unknown vector to begin with, and then we're gonna push in everything as we iterate through them. So for cell in cells. So it's a mutable iterator through this, and then, okay, so we have a cell. So for ID game object in a cell. I want to now push this game object, this mutable reference to the game object, into game objects. No errors so far. Okay, so I have these two. Then at the end, I want to. So how are we going to handle like collision? We want to like maybe find. Like in this specific case, what do I really care about? I only care about the player, don't I? So if the player, if I could extract the player, so if I remove first by type, we just use this to remove the player. Get the player, we're going to get its location. We get the player's cell, so we figure out what cell they're in, and then we just like create, okay, this might be much easier to deal with here. So instead of this entire mess, we know that the only thing that we care about is going to be the player location, the player collision. So let's actually change this name here to handle player collisions. So we're going to start by searching for the player and getting it. So it's where is that? I don't want to remove. So there's this entire remove first by type. Let's actually maybe like get first by type. And we're going to return an option that has a game object. Then, so search through, like figure out if we're going to get anything. So it's going to be very similar to what we do up here. So like figure out what our result is. So I guess it's going to be set you to be a none. Then loop through every single cell to find this game object. Okay, so now we have our hash map. It's just a reference to it, but that's fine. And then we're going to loop through everything in the hash map. Oh, you can't figure out what that is. Okay, so then you need to be iter. Oh, wait. Does the value... Okay, hold on. If I do values... Yeah, okay, this is what I want. Okay, so for game object in this one... So if object type is equal to game object dot my type, then game object. So I have game object here. So we're gonna do possible game object. Okay, throw it in a reference to the game object, and then Actually, I just want to return, don't I? Return a game object. Otherwise, if I reach the end, return a none. And you need to be an option of a reference to a game object. Okay. Now, I wonder if this needs to be mutable. Like, I might need to have like a mutable game object for this. But maybe not, because maybe I can just do this to figure out, like, find it. Okay, so we now have a reference to the game object. Let's now figure out where the player is. We can actually just like extract a mutable player just straight from this if I want. Because we have the player ID. So I could just go straight in. But let's do the let's do player grid X equals, okay, so player location.x divided by cell width okay, so that gives me player grid X All right, so now I have my, okay, so player grid X, player grid Y. I can now reach in and grab out the player, essentially. But we can now get like an actual mutable player. So we'll shadow this, like we're done with the player now. Like coming in from here. So mute player is now going to be equal to self.cells of player grid Y, player grid X, and I can't just do like do dot. We're gonna have to get mute, and then the index is gonna be a player.id. Okay, so that gives me an option of a player. Do you need to be a reference? Yeah, you do. No! Okay, so cannot borrow self.cells because I'm already borrowing like self here. I was so hoping that like that would work out for me. I could make this mutable, then I get the mutable player out of here. So I can say, I want a mutable reference to here. So you're upset with that. So of course, if I say before game objects, return sum. We have values mute. But of course, you need to be iter mute. You need to be iter mute. And then we run into the same problem. Self is, oh, then we need here. Okay, so you're happy now. So now I get, okay, so now I have a mutable reference to the game object. We have the player grid X, player grid Y. So Cannot use self that cell with because it was mutably borrowed. Because I borrowed here. I wonder if I'm running into, like, I just keep on running into this because I'm having the grid too much, or if I need to like store like IDs separately, like, and have two data structures. I have the grid and not actually storing the game objects in the grid. Right, so on 145, we borrow self here to get first by type. Okay, so to find this. We extract the player out, so we have that. We want to figure out what these are, but this isn't letting us. Cannot use self to sell with because it was mutually borrowed. Use of I don't want to like take ownership of it. And I don't want to do anything crazy like, well, maybe I do. Like if I move you up here and just say, here, you do this on your own. This is still going to have the same problem. Like I can't move things around and deal with it this way because I'm saying like I'm in this one block here. Cannot borrow self.cell with because it was mutably borrowed already. At 145, we borrow self here. Now I give ownership of the object type, but I don't really care about that because I'm just trying to get out you. Oh, let's see. What else can I do with this? I'm hoping not to like have to do a big, huge refactor for this, but it is an argument for like potentially using the ECS system instead. Or like separating out. Like I have the grid and I can track where things are by ID. And then I have just all of the objects separate by ID. And then I just say like, here, give me all the objects that are gonna be colliding together. And then grab them all, put them, like do that all separately. I don't think I would run into the same problem here that I am right now. Now in this specific case, if I take ownership of the player, I'd have to like remove the player from the grid, do collisions, and then like put the player back in. That seems unnecessary. Now, if I was to like just imagine, if I was to imagine us creating like we have our grid and then we have like all the objects in the grid, let's say. So let's imagine this here. We have let's say we have the game objects. And let's say this was a hash map of U64 game object. And let's imagine here that I just created a new one. So you know what you are. If I was to do that, I could get the player out. Then I would probably just have a vector of the IDs. All right, so before I go too far, let's actually save ourselves what we're doing. So work in progress, trying to get collision detection. Let's actually switch over to new branch and see, experimenting with separate game objects. Okay, so if I experiment with this, what would that actually look like? Now we can lean into it a little bit more. Our cells would actually look like, instead of a hash map of these, we would probably just have another vector of IDs, so like a U64. So when we create this, our cells, so instead of pushing a hash map new, we're going to push a new vector like that. Of course, this causes lots of other problems for us. So, first thing that happens when we go ahead to add something into here, we figure out our y index and our x index, and then we have our game object. Okay, so self.cell is y index, x index, and then insert our game object.id. So it's actually just going to be a push. Going to put the game object.id in there. But we also need to insert this into the hash map. And this is going to be the key and then the value. So it's going to be game object.id. And then the value is going to be the game object itself. And we give ownership to the game object's hash here. Okay, so this is fine. It clones this. That's why it works. Okay. When we query, the query changes now. Let's actually see what's next. Expected U64 found a tuple. Where are we? We're in draw now. So we don't actually care what these are. So for cell, so this is really just the ID in cell. All right. So in draw, can I find game object, the draw message context. The grid doesn't draw the objects, so this doesn't need to happen. The grid just draws the cells. And in fact, I can just remove this draw altogether. We don't need it. Expected U64 found a tuple. Okay, so now in query is going to be slightly different. We give it the start x, start y, index end y. We figure out what are game objects. So it's gonna be, this is gonna be the same thing. We get the grid coordinates. We loop through these. All we're gonna get here is for the object ID. Now I don't necessarily want to own it, so I get a reference to it, and then I want to game objects push. So before I push in, I want to do an if let sum game object equals self dot game objects dot get by the ID. Now I have this reference to the ID, and now I'm going to push that. And then we push that out there. Okay, so then this is working. Mismatch types found U64. Okay, so basically everywhere where we're doing this, we're just going to be getting the IDs. And then we have to extract it later. This is move. Okay, so in move game objects, what's happening here? And I realize I've actually been streaming 3 hours, and I am parched. I need to go get water. So before I continue to do this, I'm sorry everyone. I need to go take a quick break just to go get some more water. Maybe wake myself up a little bit more too, which will help with this all stuff. So I'm gonna put in a break here. Back. Okay, so when we're moving our game objects, so what does move mean? This is going to be the first of the refactors of sort of the nasty looking functions here. All right, so we need to check to see move game objects. Okay, so this is, first of all, we're going to go through every single game object that we have and have them move. So this is really interesting. If we take a look at what's really happening here, we're going to run update on all game objects, and then move game objects into new cells if necessary. So this is going to be very, very different. Run update on all the game objects is actually going to be pretty simple. We're just going to, let's see, for ID. Actually, this could be in the values, right? So for get the mutable values and then run update on them. Okay, done. We've updated the game objects and they've done their move. So in this case, the only one that we really care about is the what is it? The player has moved 6 frames to the right. What's next? Now we need to check to see if they're in the same cells or not. Well, we can kind of do that here a little bit. We need to know like where they previously were. So for every single object, we need a previous X and a next X. So let's go ahead and move these up here. And then we run the update and we need the next. Okay, so now we have this. We can now do our check to see if the previous X is this. Okay, so if they didn't move, then we just continue and we're good to go. If they did move, we don't change game object, we change the grid. So in this case, we have like the game object moves and like where they're going. I wonder, however, if we could just do this in like this like one area here, because we know where they were and we know where they're going. And we don't need the game object now, we're just getting the IDs. So let's see. If we get to this point, we are definitely moving. So we need to extract it from the previous index. And it's in a vector inside of there. So we need to find and remove, which sounds like a reverse no, it sounds like a filter almost. So let's find, let's see, self dot cells. So let's see if we can, yeah, we haven't touched cells yet, so we should be able to do this. So self dot cells, position, previous index X. Y first. Okay, so then I want to remove. So is there like a find and remove? Removes the first instance of item from the vector if the item exists. Well, this seems nice. Okay, so remove item, and then the item is going to be the game object dot ID. Use of unstable library feature. No, some of you might just ask, why not just start using nightly? Because then I can use all these nice features. I personally like to stay with the stable rest. That way, anybody who's watching these and sort of seeing what we can do, I'm not using anything they couldn't do at work, for example. And yes, I don't recommend that anybody use nightly things for work-related stuff. Okay, so remove item won't work for us. There's a splice, isn't there? So remove item is nightly. Does it actually say in here? It doesn't say that it's nightly only. There's retain. Let's go and check out vectors here. So I can turn into an iterator And then maybe like I'll have some more stuff to deal with, like that would help out. So there's remove. Removes and returns the element of position index. So I guess I could find where it is index-wise and then remove it. So I may have to do that in like 2 points. I can do retain, which is sort of like a reverse filter. So let's do retain. Okay, so what we're gonna have in here is our the ID. And so we want to retain it. Remove all elements such that F&E returns false. So if I want it to return I want it to be true if I want to keep it. Okay, so this is going to be the ID is not equal to GameObject.id. Okay, so that should remove it from that cell. And then I want to re-add it into the game object. I'll like re-add it into the cells. So we're going to say self.cells. And then we throw you in there. So then you get added to the next array area. And that's kind of it, isn't it? Like all of this stuff goes away. That's nice to delete more code than I was using. More code than I created. Okay, so what's next? Remove first by type. So what's the point of this? Like, where is this being used? We're resetting the game. Here's interesting. Because I've separated them out, I don't actually want to remove the player from the grid. I just want to change, so update the player's location. And then I want to handle that move entire thing. So let's see. I don't want to actually remove it from the grid. Oh, sorry, I want to remove it from the grid. I don't want to remove it from the player objects. Which makes me wonder. It makes me wonder. For the grid, do I even want the grid to be aware to hold all the player objects? Or do I want those to be like held by the main game state and passed in as a parameter or an argument to all these functions? Because if I did that, it might simplify some things. Now I separate everything else out a little bit more when I do that. Otherwise, okay, so what would this really mean? Remove first by type. I would really want to just like find the player and get the player out. And then I can remove and then re-add. So if I don't even store the game objects in here. Okay, if I don't do that, I don't store you here. Add doesn't insert the game objects in. It's just adding to the grid. Our query though, so here we want to take in the game objects. Which would be a hash map that has a U64 and a game object. Then I'll just grab it out directly from there. The type underscore cannot be indexed by reference U64. Well, didn't I tell you? This is what it is. Oh, hold on. Game objects. Okay. Hold on. I shadowed this by accident. I want game objects, then I want you to be, this is a query. So I basically just want you to be like our result. Then we can get back from there again. Okay, so then we're happy with query. Update just does this update. So if we're not aware of the game objects, they're going to be updated somewhere else. Like we're going to update them in the main update loop, but then we're going to have just like a move game objects, and then handle player collisions is going to be separate too. It's like we're not even going to do that anymore. So the grid is just going to be for like holding things, which kind of makes sense. Holding things and like getting them out again. So move game objects like in the cells. In that case, do I want to do this one at a time? Oh, I see what the problem is going to be here. Well, maybe not really, because we could check to see if it like should be moved. This runs our update. So we're having, and you're gonna have to pass in like that to pass through. So then you run update on everything and then check to see if it needs to move and then move them throughout the cells. Okay. Let's like cancel and not do our player collisions right now. Is first byte type being used? Okay, so this is like the remove first byte type to get the player out. We don't need to do this because the library is going to handle, like, we're going to get the player out there. This is going to be just like remove, remove from grid or something like that. Like maybe just a straight up remove. And then we're going to want the game object ID. And do I want to like care about what index it is? Or do I want to just like search through everything, like figure out where it is and go from there? If I take in the game object, well, that won't really help me. The game object ID is all that I have now. So I have the game object ID. I mean, if I get its width and its height, I guess like, okay, so if I get the game object, this means the grid is caring about what like is typed in here, but we have this like elsewhere. So this is precedented already. So we have a game object. We don't necessarily need to return anything anymore. We know what this is. We have to just figure out its location and then remove it. Figuring out its location is as simple as doing this. Okay, so we get its X and Y locations, and then we're going to do our good old retain as well. And so then if the game, we want it to be true if we want to keep it. So game object ID not equal to a reference like that. So this removes, this just planes up, removes it from the entire like grid. Okay. What is next? Get first by type. Are you being used anywhere? No. So let's remove you for right now. Which means grid move, I think we're not using you. Are we even using game location? I don't think we're even using this anymore. Like super simple now. Okay, this file is happy now. Of course, we still have errors elsewhere because we've changed things around. So let's come into the library and sort of fix things up. We now need to store all the game objects in here. Which means we need you to be a hash map. You're going to be U64 and a game object. Right now, we're creating the level and inserting everything into the grid there. So we need to insert the IDs. When we do insert, we're taking in the game object, but we're not actually doing anything besides pushing the game object ID. Okay, perfect. So when we populate level, we're going to have to pass in a mutable reference to the game objects. And it will mutate by adding them in here. And we'll return this too. Make you happy. So then in populate level, now for every single one of here, every single one of these. All right, so when we create a floor object, we're going to need to pass in the game objects here. Because I think this does a grid add. Yeah, it does. So we're going to add the floor. Now, when we grid add, we don't want to take ownership of this. We want just a reference. Because we're going to give ownership of the floor to the game objects. Our key is going to be our floor.id and then the floor. There we go. Now back up to here. In populate level, we create the floor object and we have to pass in. Now, what are we taking in? We can't just give ownership of this. We have to have a mutable reference to this. And it's gonna be the same here. Okay, so create floor objects. Let's also give you all right, so then we create our start. We increment, we pass in a reference to start, and let's go ahead and do a game. And the same thing with player. Then our spike. Where are you going when I hit tab? Okay. Okay, when we reset the game, this is now going to be just plain old remove. And it's going to be the game object that we're removing. Yeah, it's going to figure out where to remove it from. So we're removing the player. Oh, okay. So before we do this, we have to get the player out. Like we have to find the player from this. So let's go back to grid. See what we have for remove. Remove takes a reference to the game object. It's going to figure out where it is in the grid, and then it's going to remove it. It's going to remove it from the there. Okay, that's fine. So we need to find the player first. We don't have the player ID. I mean, we could just store that away in like the main game state, so you just like go straight in and grab it out again. Or we can just search through and find it. Because I think I can do this here. So if let some player equals self dot game objects dot, is there a find? I can probably do an itermute dot find. Searches for an element of an iterator that satisfies a predicate. Can I find first? Oh, this returns a Boolean if it can find it. We can try find it. No, that doesn't work either. Bunch of messages came in Slack from my work stuff, which pinged my phone, but not an emergency, so I don't need to care about it. Find map. No, I don't want to get that. Okay, so I don't think find is right. Hold on, let's go look at hash maps. And then turn them into an iterator. And then let's look to see what we got here. There's not much. Okay. Let's see. Oh, you're not gonna like tell me what I can do? Okay, I think this is it. So here's like find. Oh no, here it is. Okay, I was reading it incorrectly. Option self item. So find will give me what that is, and I can find. Okay, so I can use find. And you take a predicate. So searches for an element that satisfies a predicate. Find takes closure, returns true or false. Okay, so it's going to find the first one and then return some of that. So I think that's going to be fine here. So we're going to do a game object ID, and then also a game object. Now I want to return true based upon its type. So I want to say game object dot my type. Oh, and so look at this. I have like a double reference here. It kind of sucks. What can I do about that? Ah. All right. My type is equal to types player. Okay, so if I do that, now you're going to say, hey, oh, expected a comma. Okay. There we go. Okay, so expected that. Oh, did I do this with an if let? I did. If let some player. Okay, so we have this now out of here. All right. So if let some player, we do this find, and now we have our player. So essentially, we want to do this. We want to get the current player location. Well, this is where we want to like just remove the player, right? So we should be able to remove the player. And you are okay, so we remove the player from here. We set your location. We send the player moved event back to the beginning. Oh, and this is the reason why we need the old player X. So. And then we add this player back into the grid. And we set our state to not be started anymore. And then we're done. And that's reset game. Okay. And then an update, when we run update, we have to pass in the game objects. Okay, so in camera, we do, okay, grid.query, we need the game objects from that. Right, because like the grid needs to figure that out, right? Because the grid in query takes the game objects, then like figures out the location, and then grabs them, and then throws them in there. Okay. So that's perfect. So camera, you need to take in I don't have a hash map. Oh, you need to know what the game object is too. Okay, so then when I do the query, we're going to pass in game objects at the end here. I don't want you to take ownership of it. So in query, I want you to have a reference to the hash map. Okay, so you're happy there. Uh-oh, lifetime mismatch. So when I do a query here, I'm getting a reference to the game object. I want this to be a reference to a game object here. I'm pushing these in and I'm returning. I'm giving actual vector, so it should be real, and the game objects live outside. Like the game objects should be surviving because they're living way out here, but the lifetime elision doesn't seem to be working here. Data from game objects is returned here, and it's worried that game objects is going to die at the end of here, I guess. But I'm not. I'm taking just a reference to these, and I'm not doing anything to it. This parameter and a return type are declared with different lifetimes. So let's see if I need to dig. If I do lifetimes on their own, will that force me to do lifetimes in the struct, which would cause problems? What do I declare? Do I declare it here? I forget. So there's that. Game object. Oh, it's been forever since I've done lifetimes and functions. I think it's this. Like that. There we go. Okay, that works. The main library, so camera draw needs to take in reference to that game objects. Okay, so move game objects. I don't want to own, this is in the grid. when I move you, oh, okay, so I need to be mutable. Mutable reference to this. So I move game objects. That. Expected immutable reference. So this is okay. An update. No more errors. Wait, does this work? Now we don't have a collision detection on, but we should have like the player moving and the camera following it. Wait a second. Did I not have a an end? I don't have an end anymore. That failed to get in. Hold on. Everything else is in there. End. So create the floor object. Oh, I forgot to insert it into the grid. I'm sorry. It's in the grid. I forgot to insert it into the game objects. Perfect, perfect. Okay, so we did all of that stuff. I can now come back to here. Now using separate. Okay, from the grid. All right, so that entire thing that we just did, I now want to do our collision detection. So we're gonna start with the same thing. We have our physics here, and it wants to do a handle collisions with other game objects, just to see if it's in the same cell as end. Now this is really interesting because I could do handle collisions in a lot of different places. I could have it be called in grid, but at this point in time, I can now do our handle collisions outside of the grid, and I can query the grid for all the IDs that are around it. And so let's start by querying everything that's within like its own block. So maybe like 10, like one cell's up, one cell's to the left, one cell's to the right, one cell's down. And in actuality, in this case, I don't really care to the left, right? Because we're always moving to the right. Left is over here for you. That means I can just check to see one cell over to the right, one cell down. Let's maybe start with like our own. Okay, let's do our own cell. We have other game objects. All right, let's start with in the main library here. In update. While we're playing, we update all the objects. Okay, if we receive like the dead event, that's fine. We also, like, if we receive the one event, that's fine too. Oh, cool. The tab goes down to here. That's not what I want. Why is indent is like not what I thought it was anymore, apparently, according to this. That's not cool. Okay, so I want to query the grid for everything in there. So let's do it's like, I guess like just all game objects. I guess I could just do game objects. Oh, game object IDs. So let's say I want to do a query for like start X, like around where the player is. Okay, so we have to find the player first. Okay, so first things first, find the player. We do this right up here, don't we? It's basically going to be this. Okay, so we now have unnecessary parentheses around the pattern. I guess X. Really? Okay, yeah, I only needed one. Oh, is it really an if-let then? Oh, because it's a sum. That's why. I missed that. That's why I need the second parentheses. There you go. Okay, so we got the player ID, we got the player, we've extracted out of the game objects, and now we need to do a query. So for let like nearby, we're gonna query based upon our own location. So okay, so that's the start X, start Y, okay, the end X. Okay, and then our game objects. But we've already, let's see. Expected reference. Okay, so I want just a reference to you. Now this gives me the game object. I might want to get the game object IDs. It's like not actually just like query for the full objects, but like get the IDs for them. That way I don't have to, because this is a reference to them, and if I want them to do actual collision, they're going to need to do a lot more than that. Although in this case, the player's the only one that gets updated. So I think that should be fine. So now we're going to do like player and then handle, like player physics handle collision. So here is that. So we have our update here. Oh, and then everything has handle collision. So we're just handed in. Like it knows that it's gonna have it. So we're gonna have our game objects. Let's go ahead and reset this. And for right now, we'll just debug the game objects. And you're a vector of a reference to game objects. Oh wait, is there a let's go to game objects. Oh, there's a handle collision on this. Okay. Handle collision on game object with then calls. Okay, so if we have a physics module at all, we handle collisions. Okay, got it. Got it. So we can just do player dot handle collisions, hand it the nearby game objects, and that's it. So can't borrow it as immutable because it's already borrowed as mutable. Right, so this is one thing I was slightly afraid of. So what's that? That's because we're inside of here. We're going through game objects to, let's see, where is that? Right here. We're in the middle of a query to get the player. Now, if I nearby game objects, if I just clone all the game objects, I mean, I could do that. Not the best use. What are you upset about? Okay, I would want to do this clone up top. So only for playing. Otherwise, what I want to do is change things up a little bit. Like do a query based upon the locations, but not have to pass in the game objects, which probably is like the next step of what to do here. So then you're happy again, although I've just doubled my memory usage, so that's cool. Not quite double, but close enough. Then we're going to have player handle collisions and pass it the nearby game objects. So what's the first thing we want to do here? We want to check to see, so like here's all the game objects and we have our self. We want to loop through the game objects and to see if any of them are the end. Okay, so if one of these is the end, then we want to see if we're connecting with it. Okay, so if the end is near us, I guess we can start with this, right? Like, if we're passed in to the game objects, then let's go ahead and just send that. So that's what it is. It's gonna be self dot one event send dot send, and I guess like nothing at all. We want to handle this error. Okay, what does this look like? Okay, so as soon as we entered into the same cell as end, we won. Okay, that's a really good sign. Now we want to do the exact same thing if it's a so if the types, let's see, if the types is, let's see, the spike. Now this is, I guess we could just match on the game object that type. Then we're gonna send, okay, we're dead. Okay, so now we should be able to die to a spike. As soon as we hit it, that is nice, and that works really well. Okay, so that was this was all like part of our trying to get collision detection with spikes working. Okay. And I think that worked. I like this. This is good. I think that was a good refactor. So now I can't jump yet, so I can't like avoid the spikes. And we don't have a gap, so we don't have like the floor detection type thing. But I think we got enough here to do a push up. So I'm gonna go ahead and push this code. Let's close all these windows. Yeah, nothing there to update. Everything's saved. We can die to spikes again. And because I'm in this this branch here, I'm now going to merge us. So merge experimenting with separate game objects into master. Switch back to master. I'm gonna go ahead and I'll push all of this up. So I'm feeling pretty tired. I don't know, like I was much more higher energy earlier in the week, but I think like, I don't know, I haven't been like sleeping exactly on the time that I really want to be, but I've been waking up at like 6 a.m. every morning. So it has been affecting my brain. I can tell it in the morning. Like earlier and earlier, my brain starts like fading away. So what I'm gonna do is I think I'm gonna wind down now. But next time in the video, so first of all, let's close out this YouTube video part of it. So that is, let's see, this was the end of collision detection with the spikes. Okay, so I'm gonna put a marker in here, and that's the end of that, and I'll see you in the next YouTube video. So end collision